So as we look at the properties of exponents, these are the ones you're going to use as you do all of these problems. Multiplying like bases, add the exponents. When I divide like bases, I'm going to subtract those exponents. When I have a power that is taken to a power, I'm going to multiply those. Anything to the 0 power is 1, and anything to the negative power just reciprocates it. So we'll do a multiplication and we'll do a power to a power division. We'll do one of each type here. Look at number 4. We'll do that one together. I have a 4. Is there any other number to multiply that 4 with? No, it's just 4. Look at the difference between this problem and problem number 3. Like for on your quizzes, some of you listed 4 times 2 as part of your answer. What do you think I would probably want on number 3 instead of 4 times 2? All right, then I'm going to look at my x's. I have x cubed times x to the 4th. And then I have y squared. There's only one more piece that I can simplify here. What is it? So I'm simplifying those x's because I am multiplying like bases here. So my final answer here should be 4x to the 7th y squared. Can't do anything else with that particular one there. So let's look at number 6. Number 6. Number 6 has an entire group taken to a power. An entire group taken to a power. All right. So I'm going to take each piece, including the numbers, to that power. I'm going to take the 2, and I'm going to raise it to the 2nd power. So that's 2 squared. I'm going to take the u negative 2 to the 2nd power, and the v to the 4th to the 2nd power. For my numbers, I am doing what I've always done with exponents. 2 to the 2nd power is what? It is 4. Here, I'm doing that multiplication rule. Power to a power, I'm going to say negative 2 times positive 2 is negative 4. Power to a power, 4 times 2 is positive 8. My instructions specifically say I don't want negative exponents. So which one do I need to change and how do I make it positive? The u needs to change, and yes, we're going to put it on bottom. So we're going to say 4 and v to the 8th is going to stay on top. The u is going to go to the bottom, and we're just going to make it a positive because we've already reciprocated it. All right, for something like number 12, I'm going to do it by numbers, then by each variable individually. So the first thing I'm going to look at is the 4. Can the 4 reduce with anything? Well, no, it cannot. The 4 is just then going to stay right where it is. It cannot reduce. Now I'm going to look at my x's. I have x to the 4th divided by x squared. So I'm going to subtract that 2, and I have x squared. Where is x squared going to go? On the top. The y cannot reduce with anything, so the y is going to stay a y to the negative 1, which means I'm going to put it where? On the bottom. And that would be my answer. Once I get down to one number and one of each variable, I can't simplify it anymore. All right, when you have something like number 18 that's larger, I'm going to simplify the numerator as much as possible, simplify the denominator as much as possible, and then I'm going to worry about doing top to bottom, all right? So this numerator, I have power to a power, so I'm going to say x cubed squared, y squared squared. On the bottom, I'm just going to put together the terms that are alike. So I'm going to say, well, I have an x cubed times an x to the 4th, and I have a y to the negative 2 times a y to the fourth. All right? And so I'm going to simplify those individually first. In that numerator, I have power to a power. I am going to multiply 3 times 2, x to the 6th. The y, 2 times 2, y to the 4th. That is all I can do in the numerator for right now. Now I'm going to do the denominator. I have x cubed times x to the 4th. That is 3 plus 4. So I have x to the 7th. Here I have y to the negative 2, y to the 4th. Negative 2 plus 4 is positive 2. So now I have simplified the numerator as much as possible and the denominator as much as possible. I am ready to look top to bottom now with subtraction. All right? If there were any numbers, I would have just reduced them like they were a fraction. The numbers, unless they have exponents, don't do the whole properties of exponents. You just reduce however you would reduce. In fact, if it's easier for you, if the numbers have exponents, you can go ahead and put them in their normal form. 2 cubed, you could write an 8 and just reduce it like you would reduce any fraction, okay? But for the variables, we have to do our properties of exponents. All right, so you can do properties of exponents with numbers, but for this point right now, you may just want to write it out as a number and do reducing. For the x's, I have 6 on top and 7 on bottom, so I am going to subtract there. 6 minus 7 is negative 1. Where is that x going to go? On the bottom to the first power. For the y's, I have 4 on top and 2 on bottom. I'm subtracting 4 and 2. Where is that going to go? On the top. And that's my entire answer. Here it's wanting you to put this in standard form. Remember, that means highest exponent to lowest exponent. Typically, your number will come last. Leading coefficients, that is the first number when you have it in standard form. Name each polynomial. That is, you have special names for 1, 2, and 3. After that, you just say 4 term, 5 term, 6 term, etc. And then your degree is your highest exponent. So that's going to be your first exponent here once you have it in standard form. So if I have something as simple as 22, which group has the highest exponent? Well, this group does. So that's going to be listed first. Then I just go down from there. That would be the standard form. Once I have it in standard form, the leading coefficient is literally my first number, -9. Then this is a special name because it's 2, right? So this is a binomial. And the degree is my first exponent here, which is just a 4. Those are all the pieces, right? All the pieces there. Remember, for adding and subtracting, you are literally combining like terms. Just make sure you put a plus or a minus in between them. So I underline, that's just my method to make sure that I've accounted for all the terms. I have 8x cubed. I am adding, and then I'm going to find its like term, a positive 5x cubed. Then I'm going to say plus 5x. Again, I am adding, and that is a negative 5x. Then I have plus 1, and I am adding a 1. If any of these zero out, you don't have to write them. So as I add these are like terms. That's how I've grouped them. 8 and 5 is 13x cubed. Your exponents should not change on any of these. You're not multiplying. You are just adding, which means you're just combining the coefficients. The 5x and the negative 5x zero out. I don't have to write plus 0x because that is just 0, and anything plus 0 doesn't change. So I'm just going to cross that out. And then the 1 plus 1, that is just a 2. And I am done with this addition. So again, I am just combining like terms. I'm going to say, well, 2n cubed, but I am subtracting. And then I'm going to go find this other one. Well, that's subtracting a minus 2n cubed and negative 2n cubed. I typically write a plus in between these. You don't have to. You can write it as a negative 7 if you want to, but you must write this minus here before you go find what it is in common with, which is just a 1. And then we have this negative 7n. We are again subtracting, and we have this 6n. And so as we simplify these, the biggest problem here is these positives and negatives, right? So I have 2n minus a negative. That is plus a positive. So I have 4n cubed here. Then I have negative 7 minus 1. What is negative 7 minus 1? Negative 8. Then I have negative 7n minus 6n also. All right. The one thing I did not count off for on the quiz, but I do want you to do on the test, is I do want your answers in standard form here. All right. So this guy is not in standard form. Some of you may choose to add in standard form. Like I want to grab my highest exponents and put those first. Like some of you may do that process. But your final answer at the end needs to be standard form, and this guy is not. So I'm going to rewrite it, and I'm going to say, well, that 4n cubed goes first, then the negative 13n, then the minus 8. It is the same answer as what I just had, but now I have it in standard form. That's the only difference when you do one of these. So we are going to do our first terms. Some of you like to write them vertically. That's fine. Some of you like to write them out. I'll do it both ways. So we have our first terms. That is p times 3p. Some of you will like to do it this way, p times 3p. And some of you will go ahead and just say, I know that's 3p squared. Does not matter what your process is. That's fine. Outer terms. So we're going to say p times negative 6. So p times negative 6. P times negative 6. Some of you will go ahead and say, I know that is negative 6p. Outer terms. All right, inner terms. So my inner terms, those are going to be negative 3 times 3p. All right, again, negative 3 times 3p helps to write it correctly, 9p. And then our last terms, negative 3 times negative 6. Again, I need standard form, and we need to combine any like terms, right? And so as I finish this problem, I want to make sure that I'm keeping it in standard form. It will typically FOIL that way for the ones that I've given you. But again, if it's not, we want to write it in standard form. We want to combine our like terms. Negative 6p and negative 9p are negative 15. Once you have FOILed, your exponents will not go up. That should have happened in the multiplication process. So when you're simplifying, combining like terms, your exponents will not go up. They will stay whatever they were when you multiplied. So remember, if I have what's called conjugates, it is the same exact two terms, but the sign in between them has changed. When you FOIL, you will get the first term squared. It will always be minus and that second term squared because those inner terms will cancel. The other thing you can have is you can have an a plus b squared or an a minus b squared. Again, if you FOIL, that's a group times a group, right? But those will also always be the same. It will be the first term squared, 2 times those two terms. Remember, if you're doing the two terms, if it's negative, it's going to end up with a negative there because you're multiplying a positive and a negative. And then it will be the last term squared. It will always work out that way. So for this first one, this is conjugates. They're the same two terms, but just different pluses and minuses, right? So I'm going to take this 4m, that will be squared, and I'm going to subtract the 6, and that will be squared. So when I square that first term, remember the 4 also squares. So it's 4m times 4m. So this is 16m squared minus 6 squared, which we all know that is 36. Very easy foiling when you know those shortcuts, right? Very, very easy. I put these two sections together because while you can FOIL this one, you must set up special cases for the next section, right? So you want to kind of use the context clues here with these two sections so that you do the last one correctly. For this last one, again, if you don't remember it, you can write it like this if you want to, and you can FOIL. You'll just have to use that down at the bottom when you have a squared. But if we do it the way the shortcut does, we have a 4x, that will be squared. We have 2 times 4x times 6, that's our middle term. And then we have our last term squared. So once again, 16x squared, 2 times 4 times 6. That is 48, yes? 8 times 6, however you want to do it. However order you want to put that in to know it, and then 36, and we're done. And if you were to FOIL it, that's what you would get. So the instruction says use special cases to solve. It does not mean write out old school 104, 96. Y'all have all been able to do that since elementary school, right? I want you to use special cases. So if it's two different numbers, they will be the same distance away from a whole number, from a 10 multiple, right? So that's what you're looking for when you have two different numbers. You're looking for the plus minus special case, all right? So I'm going to look at 96 and 104, and they are both the same distance away from what number? 100. So I'm going to rewrite the 96 as 100 minus 4. That's just 96, right? And I'm going to rewrite the 104, 100 plus 4. This is the same thing as my conjugates. Same two numbers, they're just plus minus. So I should be able to take the first number squared and subtract the second number squared. And that will be my answer. So I'm going to say 100 squared minus 4 squared. What's 100 squared? Well, I just list the zeros twice, right? I have 1, 0, 0, 0, 0, right? 10,000. And I'm going to subtract what? Well, I'm going to subtract 16, right? Now, you can do this long if you want to. I just subtract 20 and add 4 to it. But you can do it however you want. 9,984 is 10,000 minus 16. All right? You're just using a special case there. You're just using a special case. Is when it looks like something squared. Well, that should look like the second one that we did up there. That is your two of the same kind, which means the first one squared times 2 times a times b squared. All right? So I'm going to take this 83 and break it up into 80 plus 3. That's the easiest thing to do here. You could say 90 minus 7 if you wanted to. Most people don't do it. They normally always do addition. But you can do it either way. 80 plus 3 squared. That is 83 squared. It's exactly the same thing, right? 80 plus 3 and the group squared is 83 squared. And I'm going to use my special case. I'm going to say, well, that's going to be 80 squared plus 2 times 80 times 3. And then plus 3 squared. 80 squared, I'm just going to take the 8 and square it. And then do 2 zeros. 2 times 3 times 8, well, that's 48 plus that 0, so that's 480. and then plus 9. So 6,400 plus 480, 6,880 plus 9, 6,889. 6,889, 6,889 is 83 squared.